Section 5 is on naming ionic compounds. And if you've been looking at your worksheets, you'll notice there's quite a bit of work associated with this. So let's get on it. Monatomic versus polyatomic ions. I kind of mentioned this at the end of the last video, but it's worth mentioning again. If I refer to something as a monatomic ion, mon meaning one, right? And atomic for atom, so one atom ions. This would be something like a magnesium +2 ion or a bromide ion. Something like that where there's simply just one atom. And these, remember, formed binary ionic compounds. You have two monatomic ions that are combining. So, for instance, this one here, this plus sign should be up here for sodium. A sodium ion plus a fluoride ion react in a 1-to-1 ratio to give you sodium fluoride. We'll learn how to name it here in a moment. The electron is lost by the metal and is gained by the nonmetal. It physically loses it and is gained by the nonmetal. Okay, so in ionic compound formation, the metal loses the electron, the nonmetal gains the electron. And then polyatomic ions, again, I mentioned this in the last video, just saying it again. Ions made up of more than one atom. The whole thing acts as an individual ion. You can't separate polyatomic ions apart. The charge applies to the whole ion. Okay? When it comes to naming oxyanions, these are going to be, and I should clarify some terminology here. If you hear me refer to something as a cation, okay, that is a positively charged ion. And if you hear me refer to something as an anion, that is a negatively charged ion. Okay, so these two terms, I would put those into your notes as well, even if they're not on here. So if something's called an oxyanion, what that means is it's an anion, so it's negatively charged, and it has oxygen in it. So, full definition, a polyatomic ion composed of an element, usually a nonmetal, bonded to one or more oxygen atoms. So this is something like here, this is a phosphate ion, PO4 with a -3 charge. It's got the oxygen in it. It's also got the negative charge, making it an anion. SO3 with a -2 charge, that's a sulfite ion. It's an anion, and it's got oxygen in it. So when it comes to naming them, the rules are down below. Let's identify the ion with the greatest number of oxygen atoms. This ion is named using the root of the nonmetal and the suffix -ate. Okay, so for instance, you may have noticed on your ion sheet something like that and something like this. Okay, NO3 with a -1 charge and NO2 with a -1 charge. Very, very similar. So how do you name these two? What's the difference? Well, the rule said identify the ion with the greatest number of oxygen atoms. That would be this one. This ion is named using the root of the nonmetal and the suffix -ate. So the root here for that one is, right, nitrogen, so the root being NITR and the suffix becoming -ate. Okay? And then identify the ion with fewer oxygen atoms. This ion is named using the root of the nonmetal and the suffix -ite. So I'm still keeping the root here, NITR for NO2 with a -1 charge, and the suffix is now -ite. So that is nitrite. So nitrate versus nitrite, that's how you would tell the difference. And down below here, here's another example. The SO4 -2 ion versus the SO3 -2 ion. This is a sulfate ion. This is a sulfite ion. Notice, it doesn't matter what the number of oxygen is. It's just which one has more and which one has less. Okay, so even though this one has 3 and this one has 2, the 3 is the 8 here and the 2 is the ite here. And over here, the 4 is the 8 and the 3 is the ite. It's not about a specific number, it's about which one has more. Okay, so what about if we have oxyanions with more than 2 possible states? So here we have 4 examples of very similar looking ions. ClO4 -1, ClO3 -1, ClO2 -1, and ClO -1. And then you may have seen these on your ion sheet already. But let's figure out, if let's say you didn't have your ion sheet, how you could do this. The oxyanion with the greatest number of oxygen atoms is named using the prefix per, the root of the nonmetal, and the suffix -ate. Okay, so if you have more than 2, you're going to end up having 4, and for that to work, what we're going to do is follow these rules. So this one's got the most total. It's got a prefix per, And then it says the root of the nonmetal, which is chlorine, okay, chlor, and the suffix ate. So that's why ClO4 is called perchlorate. Okay. The next one down, the oxyanion with one fewer oxygen atoms is named using the root of the nonmetal and the suffix ate. So this one just does not have the per in it. This is just chlorate. Okay, one beneath that, the oxyanion with two fewer oxygen atoms is named using the root of the nonmetal and the suffix ite. So no prefix here. Root plus suffix ite, ClO2 -1 is chlorite. And the last one, ClO with a -1 charge. The oxyanion with three fewer oxygen atoms is named using the prefix hypo, the root of the nonmetal, and the suffix ite. So that becomes hypo as the prefix, chlor from the root, and the suffix ite, hypochlorite. So, even if you don't have, say, one listed on your ion sheet, if you had something like, I don't know, this ion, IO3 with a -1 charge, it's going to follow very closely to what this one is doing. Right? You take the root of it, this is iodine, so iode, and then change it to the same suffix, ate. That's the iodate ion. Okay, naming ionic compounds. There's a lot of rules here, and these are very important to get down, but we're going to practice them in a moment. So rule number 1, name the cation first. Remember, that's the positively charged ion, followed by the anion, negatively charged ion. For monatomic cations, use the element's name. So if it's just a single atom and it's a metal, use the element's name. For monatomic anions, use the root of the element's name plus the suffix ide. Okay, so if I've got a compound here, CsBr, the cation is the first one listed, and that's what's always going to be listed first. Cs is cesium. Okay, that's where that name comes from. And Br being bromine, but the suffix changes to ide since it's a monatomic anion. So that is cesium bromide. Number 4 says, distinguish the different charges of the transition metals if necessary. Okay, well, cesium's not a transition metal, it's a 1A metal. But let's say I had something like iron. Well, iron can have multiple charges. Iron can be +2 or +3, depending on what it's bonded with. So you're going to have to distinguish the names. Well, iron 2, okay, this one here corresponds to that one, and iron 3 corresponds to that one. This is important to realize. The 2 here corresponds to the charge, not the total number of iron atoms, which we're going to have an issue with here probably in a little bit. Don't confuse that. This is iron 2, okay, with a +2 charge, and iron 3 has a +3 charge. If an anion is polyatomic, simply give the name of the polyatomic ion. Okay, so if it's not a monatomic anion, if it's a polyatomic ion, it's going to be the anion. Just give the name of it. We're going to do a few for practice here in just a moment. Okay, here are a few of them for us to try. This first one, NaBr, right? We name the cation first. In that case, this is sodium. And then we're going to name the anion. Here it's bromine, but since it's monatomic, we're just going to change the suffix to ide. So this is sodium bromide. Is the name of that one. CaCl2, the name of the cation is calcium. And the name of the anion, well, again, it's monatomic, even though there's 2 of them, okay? That doesn't matter. There is only one atom in terms of what it's bonded to here, one type of atom, right, one element. It's chlorine, so we're going to change that from chlorine to chloride, right, monatomic, so calcium chloride. KOH, okay, this time we're going to name the cation first, and that is potassium. And then what comes after that? Well, okay, this is where kids will oftentimes get confused. This is not oxygen, hydrogen, right? This is now a polyatomic ion. So go to your ion sheet and find OH, and you're going to see that it's OH with a -1 charge. And all we're going to do here is just name that. Well, OH with a -1 charge, its name is hydroxide. Okay? So whenever you get something that is not monatomic and polyatomic, go to your ion sheet. You're allowed to use that on quizzes and tests, so use it. Don't call it something that it's not, right? I get a lot of like oxide hydride or something like that. No, just go straight to your ion sheet, look up what it's called, and use that. Okay, this one's got a lot of stuff going on. Cu parenthesis NO3 parenthesis 2. Okay, well, Cu is copper, so we'll write that down. But it is a transition metal, and we said earlier that transition metals can have multiple charges, so we have to figure out what charge it has because something is going to be in parentheses after it. Okay, now copper can be +1 or +2, so how we know what it's going to be here, what Roman numeral we're going to put here, depends on what it's bonded to. Well, it's bonded to 2 nitrate ions, and those nitrate ions each have a -1 charge. So if you're bonded to 2 of them, each one is -1. That means there's a grand total of -2 charge here from this side of the compound. Therefore, the copper has to have a +2 charge. Okay, so we're going to name this copper 2 because the copper has a +2 charge, and the NO3 ion's name is nitrate. Okay, so that's what that one is. We don't do anything dinitrate or anything like that. It's just copper 2 nitrate. Okay, so just kind of recapping how this one's different than everything else. Everything up here so far, these have been main group elements. Copper is a transition metal, so I need to make sure that it only has 1 charge. Well, it doesn't. It can have multiple charges. Then to figure out what I need to put in the parentheses afterwards, which Roman numeral for which charge, depends on what it's bonded to. Okay, it's bonded to 2 nitrate ions, which means this whole side is -2, which means the copper needs a total of +2, and there's only 1 of them, so it's got to be copper 2 nitrate. Okay, if we look at this one right here, Ag2CrO4. Well, Ag on your ion sheet is silver. And even though silver is a transition metal, silver will only form 1 charge. It forms a +1 charge. So in that case, okay, and if you're looking at your ion sheet, you'll see this as well. We don't have to put this parenthesis and charge in Roman numerals after it because there's only 1 possible charge. Okay, so that's silver. And then, again, don't freak out when you see this, all right? The CrO4 right there, okay, that is a polyatomic ion. It's on your ion sheet. That is called the chromate ion. So we just name that. So this would be silver chromate. Okay, that's all you have to do, silver chromate. Don't overthink it, just go straight to that ion sheet. And we don't, again, put the parentheses here with the charge, silver would be +1. We don't do that because silver can only form 1 charge. You have to look out for ones that can form more than 1 charge, like copper. All right, this one down here, all right, this is a little tricky because the cation is not a metal, it's this NH4 ion. Which is at the top of your ion sheet. This is called ammonium. All right. So when we start naming this is ammonium, and then the ClO4. That's the second part of this, and that's on your ion sheet as well. That is a perchlorate ion, and we talked about it earlier in this video. So that one's called ammonium perchlorate. A few off of your worksheet for practice. K2O. All right, name the metal first, the cation first. That is potassium. Okay, and then name the anion next. Well, that's oxygen. It's a monatomic ion, so it's oxygen. Change the suffix to "ide." That is potassium oxide. Okay, this one here, name of the metal is magnesium. Okay, and then the second part of this, nitrogen, it's not on your ion sheet, but you can think this through. Since it's a monatomic anion, take the root of it, NITR, and change the suffix to "ide." So that is magnesium nitride is the name of that compound. Okay, number 7 on the section 5 worksheet, Fe parenthesis NO3 parenthesis 3. Okay, well, Fe is iron. All right, and if you're checking your ion sheet, iron can have multiple charges. It can be +2 or +3, so we are going to have to figure out what charge it is. There's going to be something in parentheses after it. It's a transition metal, with multiple charges? Well, it's bonded to 3 nitrate ions. Each nitrate is -1 as a charge, so a grand total of -3. I've only got 1 iron atom in this compound, so to counteract the -3 from the nitrate, the iron's going to have to be +3, which means this is called iron 3. And then we just name the polyatomic anion nitrate. Iron 3 nitrate is the name of that one. Okay. Number 9, COCl2. CO is cobalt. And cobalt is a transition metal with multiple charges, so we need to indicate what charge it's going to have, and we look at what it's bonded to. It's bonded to 2 chlorine atoms, chloride ions. Okay, so we can go ahead and write that part in, since that's going to be the second part of the name, chloride, right? Each chloride is -1 in charge for a grand total of -2 coming from the anion part of this compound. So that means cobalt, since I only have 1 of them, it's making up for all of that. Cobalt has to have a +2 charge. This is called cobalt-2 chloride. All right, and 22, ZnF2. Zn is zinc. And if you look at the table, zinc is a transition metal, but zinc can only form 1 charge if you're looking at your ion sheet. It only forms a +2 charge, and we don't have to put the parentheses and indicating a charge after it because it can only do one thing. Zinc, and then we name the other one fluoride. Okay, and lastly, we're going to skip to the next page on your worksheets and do 31 and 33 as an example. So this is going to be the reverse process where I give you the name, and then you have to work backwards to figure out what the formula is. So sodium sulfite, number 31. What you'll want to do is find them on the ion sheet if you don't already know what their charges are. Sodium you might be able to know just because it's a 1A metal. Is going to be +1. Sulfite has the formula SO3 with a -2 charge. And then it's just doing what we did in section 4, which is figuring out what ratio do these combine in. I'm going to need 2 sodiums for every 1 sulfite. So that formula is going to be Na2SO3, like that. Number 33, ammonium dichromate. Ammonium has this formula, NH4 with a plus charge. Dichromate, Cr2O7 with a -2 charge. Okay, and I'm going to need then 2 ammonium ions for every 1 dichromate. And this is where we're going to have to worry about parentheses. I have a polyatomic ion here, and I've got more than one of them. So even though ammonium's formula is NH4, okay, and dichromate is Cr2O7, what I need to do to this ammonium is put it in parentheses and put a 2 after it. Again, that's telling the reader that you have 2 ammonium ions. You don't write N2H8. Don't write it like that. That's not the way that we read it, so do it like this.